What's up, intermediate algebra? It's Mr. Smith here, and I got a great video for you today. It's going to be a short one, but, well, they're always short because, you know, I'm too cheap to buy a full trial to this Screencast-O-Matic website. I got to keep it 15 minutes or under. But I think this is a really important video. It's over the concept of linear functions. And I'm going to use Desmos to show a couple things, and then I'm going to shoot over to OneNote and draw a little bit. But the idea of a linear function is some function that is occurring where there's a constant rate of change. You're going to hear me say that phrase a lot. Constant. Why is it not? Yeah, let's just jump over here. And I think Spencer said he remembered Miss Case saying that, but linear functions, notice that in linear there's the word line, so you kind of are going to know what they look like on a graph. It might be a positive line like this. It might be a negative line going down like this. It might be a perfectly flat, whoa, that's horrible. Let me just try this again. It might be a perfectly flat line, which would have a slope of 0. Might be a vertical line, which would have an undefined slope. But you get the idea. Linear functions are lines. And the reason they're lines is because they have a constant rate of change. And I think the best way to explain this concept is to think about someone working a job, especially a teenager who gets paid by the hour. So let's talk about Mr. Smith when he was 16. I used to work at Hobby Lobby, and it was my job in the summer to work in the back and put together furniture. It was my job in the winter to set up all the Christmas trees and all the Christmas ornaments, and I almost went mad every year from listening to Christmas music for my 8-hour shift on a Saturday, every single Saturday. But here's an example of a linear function in the real world. I made $7.50 per hour. Okay, that's a constant rate right there. And that's two variables. One variable is time. Okay, so the X is going to be hours worked by me. And then the Y is going to be money made. So there's two variables being measured, just like the Desmos activities that we did last week where we were measuring like time and height or time and volume. Linear functions also involve two variables, and they do things that increase or decrease with a constant rate of change. So for example, the formula would be y equals 750 times x. So however many hours I worked, I would plug that in there, but I would only make 750 per hour. So let's say I worked an 8-hour shift. I would plug in an 8 for the x. 8 times 7 is 56, and then plus 4, I'd make $60. So, and honestly, we can practice our function notation that we learned the other day. Let's do this. Money made per hour. Let's do that. So, 750 per hour. So if I do M of 8, how much money would I make after 8 hours? That'd be 750 times 8. So the money made after 8 hours would equal $60, which is not ideal, but it's a couple of milkshakes from Dairy Queen and some burgers, so it was worth it. Okay, so linear functions have a constant rate of change, and this first thing that we're going to talk about for these next 10 minutes is how to graph functions 3 ways. Okay, so let me show you a linear function here. We could make up y equals 3x. Let's just do y equals x. Notice, here's a point, and this is the most basic linear function there is. It's over 1, up 1. There's the point 1, 1. Over 2, up 2. But like basically, here, I can even draw it on the screen and be the best way to do it. It's a constant rate of change because we go up 1, over 1, next point. Up 1, over 1, next point. Up 1, over 1, next point. It's the same and going reverse. Down 1, left 1. Down 1, left 1. This is the constant rate of change. It's a slope of 1. Okay? If we put a 2 here, it's a slope of 2, and notice it's steeper. If we put a 3 there, it's a slope of 3. It goes up 3 over 1, up 3 over 1. Okay, if we put a negative 2, now it's going the other direction. Okay, if we put a negative 5, now it's pretty steep negative. If we put a fraction, like a 1/5, notice it gets flat. Instead of with a 5, it's up 1, 2, 3, 4, 5 to the right 1. But with a 1/5, it's up 1 and to the right 5, which makes it a lot steeper. Excuse me, a lot more flat. Okay? And the most common way that you graph equations is called the easiest form to graph a linear equation is slope-intercept form, which you've seen before. I know you have, so I'm just reviewing today. Y equals mx plus b. Okay, m is your slope, b is your y-intercept. You can see here as we change the slope, as the slope gets higher, it gets steeper. And what does the b do? The b is the y-intercept. Look what happens when I move this. What's happening here? The graph is going up and down on the y-axis. If the b is 5, it slices through the y-axis at 5. If the b is negative 5, it slices through the y-axis at negative 5. So the b value tells us where the line is slicing through the y-axis. So if I wanted to graph the line, let's just make something up here. Y equals 1/2 x minus 3. Let me draw my coordinate plane. Yikes. Gotta do a better job. I can't keep my hand steady. There we go. Y equals 1/2 x minus 3. The way I'd graph it is I would first just put my starting point at negative 3. 1, 2, 3. Right? Your y-intercept, which is right here, is always your starting point. Do that first. Remember, this is the y-axis. This is the x-axis. Okay, so once we have our starting point, then we look at the number that is in front of the x. And that number is our slope. And you remember that slope is rise over run. Okay, it's also your vertical change. Vertical change, so how much we're going up and down over your horizontal change, how much we're going to the right. Okay, you always go to the right. So this is saying we go up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. If I wanted to, I could go down 1, left 2. Down 1, left 2. But that is our line right there, graphed in slope-intercept form. Okay? We're going to practice slope-intercept form tomorrow in class. Okay? Just remember, slope-intercept form, y equals mx plus b. It's the best for graphing. Okay? It's the best for graphing. But I want to talk about another form, and that's called point slope. And the point slope form is very underrated. Okay? Because all you really need to graph a line, I don't know if you know this, but all you really need are 2 points. If I have the point, let's say, let me do a better job putting this right on the line. That's better. If I had the point 2, 3, which is right here, and then I have the point, we can pick any other point, let's go negative 1, 1. I have a line. All you need to make a line is 2 points. And all you need to find a slope is 2 points. Okay, so I want to right here talk about the equation to find slope. The way you find slope is you take your 2 y values and you subtract them. Basically, you find the difference between them. That's what subtraction is, you know? You find the difference between your 2 y values. PC's in low battery mode, uh-oh. And then you find the difference between your 2 x values. You've probably seen this formula before. This is the equation for slope. And I don't want you to feel like you have to memorize that. I want you to know what's actually going on. This is just the difference between your y values. Okay? The difference between your y values divided by the difference between your x values. So, okay, I'll be done in a second. The difference between, dinner's ready. The difference between your x values. So let's do this really quick. What are my y values? So this is an x value. This is a y value. We'll actually call that x1 and y1. And then this point over here is another x value. We'll call that one x2. And this one, we'll call it y2. So what are the difference between my y values? What is y2 minus y1? Well, that's just going to be 3 minus 1, which is 2, divided by, now let's do the same thing with our x values. Let's subtract those. 2 minus a negative 1. That's going to be a little trickier. 2 minus a negative 1. That's 2 plus 1, which is actually 3. So the slope is 2/3. Let's see if that's right. Let's see if we can go up 2. Because remember, this is the vertical change, and this is the horizontal. Let's see if we can go up 2 and right 3, and see if that's the right slope. Up 2 and right 1, 2, 3. That's exactly the slope of our line, is up 2, right 3. And so the way that we're going to calculate slope is using this right here. So you want to write this down. Note this. Slope is always m. So we'll say m equals that right there. Okay, that's the formula for slope. So if all you need to graph a line is a slope, is a couple points, then let's finish the video by me teaching you this second form, which is honestly almost more useful than slope-intercept. Everybody loves y equals mx plus b, but point slope is super underrated, and it's going to get the last 3 minutes of the video. Okay, the equation for point slope tells us that if we have a point, if we have just any x coordinate and we have the slope, then we can create the equation of the line. And the formula is that you do this. You do y minus your y coordinate, so I'll put a little 1, equals your slope multiplied by x minus your x coordinate. Okay, and I know this looks a little weird, but it comes straight from this, y2, y1, x2, x1. It's a form of that equation. And so this right here is our slope. And then this right here would be your y value, and this right here would be your x value. So let me show you what I mean. If somebody gave me 2 points and they said, make the equation of the line, let's say, that connects the points 1, 5, and 5, 9. Make a line that connects those. Okay, well, I need the equation first, so I need to find my slope. So to find my slope, I do my difference between my two y values, so 9 minus 5, divided by the difference between my x values, 5 minus 1. 9 minus 5 is 4, 5 minus 1 is 4. So hey, my slope is 1. So I know my slope. So I'm halfway there for my point slope form. I now know the slope. So the only other thing I need is a point. Well, guess what? I was given 2 of them to start with, so I'll just pick the smaller one, 1, 5. So here's my equation. Y minus y1, which is 5, equals my slope, which is 1, times x minus the x value, which is 1. Notice how 1, 5, I used this point right here, 1, 5, in my equation. And so this equation right here should go through the points 1, 5, and 5, 9. Let's go test it. Y minus 5 equals 1. Y minus 5 equals 1 times x minus 1. Was it x minus 1? Yeah. So let's see if it goes through the points 1, 5, and 5, 9. 1, 5, is that on the graph? It is. And then 5, 9, it is. So, as you can see, in conclusion, point slope form is right here. And all you need to graph in point slope form is a point and a slope. So we are going to use point slope form and we're going to use slope intercept form tomorrow. So if you want to refresh those and watch this video again and just make sure you have those formulas memorized, then you will be set and ready to try to graph tomorrow. Have a great night.